All right, let's get started. Okay, so this one we have start with acetophenone. Okay, react with ethanol twice. First time go through hemiacetal, and the second time you get to acetal. Okay, we use acid as a catalyst. All right, use an acid. What happened in the first step? If you remember, protonation. So we protonate that oxygen. This is gonna become more reactive now. So take ethanol, even weak nucleophile as ethanol can attack right there. Okay, all right, recognize that that's a strong acid, so remove that proton right there. Take another molecule of water, or take ethanol. You can use ethanol as well. Ethanol might be the more reasonable one because it looks like a solvent. Okay, and I'll take water or ethanol, attack the proton, remove the proton. Now that hemiacetal, halfway now. Okay, all right, next one we're gonna go to acetal. So look like we have to kick out that OH group, that water. Okay, so we're gonna do pronation. Again, repeat what I just said in a previous video. You can pronate a ethoxy group, you can pronate the hydroxy group. It's up to you. Both work. These are in equilibrium. They all exist. Okay, but if you pronate OH group, you pronate the ethoxy group, you go backward. It doesn't go forward. We try to get to acetal. Okay. All right. So we're gonna pronate that OH group. If you want to make it bleed, pronate it so you get to this point. And then, all right, we're gonna kick that out now. Let's say, what do? Can I take the alcohol attack like that? No, that's too strictly hindered. Do not do it like that. This is not an this is an SN2, and that's too strictly hindered. Okay. So we're gonna take the lone pair of the ethoxy group from double bond and kick out that water. Okay, and right here, all right, one more molecule of alcohol can come in now. So take ethanol, attack on the carbonyl carbon. And then you should recognize that that's a strong acid. Remove the proton, take ethanol, take water, and then grab the proton. And that here's an acetal. Okay, all right, so ethanol react twice on aldehyde ketone to get to acetal. Yeah, so we have two molecules of ethanol. Let's take a look at this one. This one you should do on your own. Okay, so look at this compound. This diol is called ethylene glycol. It's made from ethylene, like CC double bond, basically. Okay, made from ethylene. So we have ethylene glycol. We have two alcohol on. There's two carbon on here. Anyway, you can see that this is the one equivalent of ethylene glycol react with a ketone. Okay, if you go back one slide, I'm gonna go back one slide, 1, 2, and 3. Okay, so normally two alcohol molecules can react with aldehyde ketone to get to acetal, but this only one is required because this compound got two alcohol groups on it. Okay, and it will lead you to the cyclic acetal. All right, can you draw the mechanism? Try to at home. Okay, and you can look up online. This is very known, the mechanism. Okay, because we're going to use the cyclic acetal as protecting group. Look at on the next video.